Hello students, welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Apex Selenio, or preferably you can call me Mr. Peart, your math instructor, your Caribbean CSEC math instructor. In today's video, which is part 3 of our 4-part series where we're talking intensively and exclusively about factoring techniques. This is a very important branch of mathematics, and we are in fact at a very important and crucial aspect of the factoring technique. This particular factoring technique is exclusive and it is completely different from all the other factoring techniques. It has a complete technique by itself, and so part 1 and part 2 is not necessarily a prerequisite of this skill. You might find, like later on in this video, where part 1 actually will contribute towards you solving a few of these questions, but as a video, as a topic in itself, it has an independent technique, factoring technique by itself. And in today's video, we're going to be talking about the difference of two squares. All right, there are some tutorials out there that will explain to you how to do the difference of two squares. Like I said, we are all math teachers, we teach the same way, but for my particular videos, I teach students that are doing crash course mathematics. And so these students really comes to me with gaps in their learning. They come with weak fundamentals in math. These students that I have been teaching over the course of 13 years, including my current year students, are in fact students that have struggled with math for many years. And so the aim and objective of my videos, my channel, my whole entire school that I'm building here online is to teach you guys the language of the universe and to give you a little bit more appreciation for this beautiful subject known as mathematics. In fact, it's not a subject for me, it is a discipline, it's a lifestyle. So we're going to be diving into this technique, very important aspect of algebra, very important aspect of mathematics, very crucial aspect of mathematics here. All right, so if you guys have found some values from the part 1 and part 2 videos that I've already released, do of course leave a like, leave your comments, leave your thoughts, suggestions, questions down to the comment section below. Share this out to a family, to a friend, to a current classmate who is struggling with this type of math or with any level math. If you are in fact in college, heading into college, coming up on this channel for the first time, you're in need wanting a personal tutor, a one-on-one tutor. If you know anybody who is in need of these kind of service, you can reach out to me at the links or any one of the links in my socials pinned in the comments or in the description of this video. So without further ado, let's dive right on in. Now I want to kickstart this video by making an apology. I do in fact got cut off in the latter part of part 2. I actually ran out of some storage. So I wanted to end the video properly by saying subscribe, hit the like, share, and leave your comments. So I've said it and I'm saying it again. Hit that like button, guys, and let's dive right on into this video here. So difference of two squares. This factoring technique is a very unique one and can be easily understood from an arithmetic point of view. Now, the general form of a difference of two squares, and I've left a space here because of course I wasn't able to really get that x squared y squared with the keypad, so I'm going to put it here. It's going to be the general form of a difference of two squares is x squared minus y squared, where it can be expressed or re-expressed as x plus y in bracket and x minus y. So you might be questioning yourselves now, why or how, or how do you get an expression as x squared minus y squared to become x plus y by x minus y. Now, I'm going to be breaking this concept down to you from two points of view. I'm going to be breaking it down from an algebraic point of view, and we're going to be using the knowledge that would have or should have been garnered from a previous video that I did about the distributive law. So the distributive law is really the basis of which this expression has been derived. Now, as you can see here, I have x squared minus y squared, which basically is the same thing as x plus y in bracket and x minus y also in bracket. Now, how is that possible? How did x squared minus y squared becomes x plus y and x minus y? Now, to understand that, we can just basically try to distribute this binomial expression. And so if we distribute, and if you had watched that video, I will pin a link in the description box below, how to expand a binomial expression, then you'll know that we use what is called the bird beat method, or more familiar on YouTube as the foiling technique, where we take the first term and multiply it with the last two terms. Let's just use a nice little arrow here. Okay, so first term with the two outer terms, then we're going to take the second term and multiply it with the last two terms again. Whoops, pardon me here. I'm going to take the, okay, like that. Whoops, pardon me here, guys. Sometimes it does give me some problems here. All right, so that's what we're going to be doing. So we're going to be taking the first to multiply the outer, and then we're going to take the inner to multiply the last. That's why we get the first multiplies the outer and the inner to multiply the last. So we call it the FOIL technique. So if we take x and we multiply it by x, you're going to find here that we end up with x squared. I've already done the working out for you here, but I'm just walking you through the process, right? And then of course we're going to take x and we're going to multiply it by negative y. We're going to end up with negative xy. That's why we have that there. Then now we're going to be using the y here, the positive y, to multiply the x, and we're going to get xy. Some of you guys will write yx, but conventionally when we're writing down algebraic expressions, we usually write it down in alphabetical order. So yx is the same thing as xy, but since as we have xy here, might as well we just keep it as xy here so they can obviously look like the same term. And then finally then we're going to end up with, say here, we're going to end up with y multiplied by y, so we end up with y squared. Now if you pay close attention to what is in the bracket here, and if we just get an eraser here and erase this here, all right, if you look carefully at what is in the center, you'll realize that we have what is called the additive inverse identity, and that simply means that we're adding the opposite expression to itself. So negative xy plus xy is sitting as xy minus xy, and xy minus xy is 0. So if we cancel these out, guess what happens? We end up back with x squared minus y squared. So technically then, x plus y by x minus y, when expanded and simplified, will give us back x squared minus y squared. So that is the fundamental basis behind why we can express an expression or any expression that is, you know, where the first term is raised to a power of 2, the second term is raised to a power of 2. It can be rewritten or re-expressed as x plus y by x minus y. Now this is crucial, this is critical, because in algebra there are limitations to what we can add and subtract. If you had watched any of my algebra tutorials or my algebra classes that I posted, links to that playlist will be pinned in the description and in the comments of this video. You will remember when a lot of my students and I, we were talking extensively about what can be added or subtracted, and we stated that only like terms can be added, subtracted, added and subtracted. But if it's unlike terms, we are not allowed to add or subtract. Fortunately, we can in fact add, we can in fact multiply and divide like and unlike terms, but when it comes to unlike terms, we are not allowed to add or subtract them. So evidently then, there's no way for us to take away y squared from x squared, regardless if it has the same power or not, because they are not of the same origin. Now, moving down to the arithmetic application of this then. Let's say that you went on a multiple choice exam. Let's just say hypothetically that you are a very weak math student and you go on a multiple choice exams where there are no calculators allowed, or you're just in one of your classes and you get an expression to work out that says 10 squared minus 6 squared. Now, naturally, you have some students that have very weak fundamentals. They will make a mistake thinking that 10 squared is 10 times 2. Why I can confidently say this is because I've had students in my classes over the course of 13 years that have ended up in my class signing up to CXE that make errors, critical errors, by saying 10 squared is 20. So we want to get rid of that. Definitely that's a no-no when it comes to this level of math. 10 squared is 10 multiplied by 10. Alright, this video is geared towards building students in a short space of time to become math wizards. That's the aim. So 10 squared, ladies and gentlemen, boys and girls, 10 squared means 10 times 10, which is 100. So naturally then, from an arithmetic point of view, a lot of you guys would say 10 squared is 100, and 6 squared is 6 times 6, which is 36, and 100 minus 36 is 64. So arithmetically, this is easy, right? Arithmetically, this is easy. But here, because we have just learned that if we have an expression where one of the terms is raised to a power of 2 and the other term is expressed to a power of 2, then we can have the first plus the last, and then we have the first minus the last multiplying each other. So then you realize that 10 plus 6 is 16, and then 10 minus 6 is 4. Remember, we have x plus y. This is the x, this is the y, so that's x plus y, x minus y, x minus y here. So that's what we're looking at here. So we're re-expressing it like that. So therefore then, 10 plus 6 is 16, and 10 minus 6 is 4. Bracket means to multiply. Guess what happens? 16 times 4 is 64. Really nice, right? Really nice, definitely. So you can see that we can get the same answer using two different approaches. So you might say to yourself, hey, why are we not allowed to just do one attempt or one method for every question? Because like I said before, algebra has prevented us from doing certain things. When it's very easy for us to say 100 minus 36, we can't obviously say y squared minus x squared because they are not of the same family. They are not like terms. So we're limited to what we can do. So when it comes to algebra, then this method is obviously the only method to simplify the expression. And like you can see, arithmetically, whether you do it this way or you do it this way, you're going to get the same answers. So that's the key importance there in terms of why we do what we do. So hopefully that kind of clears up, if you've ever learned this topic before, why is x squared minus y squared now or can be expressed as x plus y by x minus y. So that is what we're trying to emphasize in this video here. So we're going to have a series of examples here that will demonstrate how useful this technique is. Now at the end of this video, you will find quite fascinating that this is actually a much easier factoring technique than all the others that you've learned. In fact, in my professional opinion, find this is the easiest expression to factorize, but it is the hardest one to identify. Because when you're in the exam, it's a lot different than when you're actually sitting down, having a snack, having a drink, having your books in your hands, not under any exam pressure, not under any time management, not under any supervision. It's really easy right now that I'm talking. But when you're in the actual exam and you are seeing 1, 2, 3 different questions that you don't like, questions that you like, it's all a blur. then of course sometimes you can make that odd error. So at the end of this video, my aim and my objective is to get you to confidently attack these questions in seconds. Doesn't take any time for you to run through these. Now I've structured my questions in such a way that we're going to gradually increase the difficulty of these questions. And later on, at the ending part of this video, you will find that I will combine a couple of the other factoring techniques with the difference of two squares. So let's dive right on in here. Now, before we dive right on in, for some of you students who like a set of instructions, then for some of you, you might remember that, oh, okay, so it's just the first and the last term plus the first and the last term minus. If you're smart and you know it like that, then these instructions do not apply. But if you're a student that likes instructions, step-by-step process, then I've put together the steps for you here. So basic steps of the difference of two squares factoring. Step 1, ensure, and this is very, very important, guys, ensure that all the terms in the expression, the given expression, are expressed to a power of 2. This is so important, because so far you haven't really seen an example where one of the term isn't raised to a power of 2. It is at this point your assumption that when you get an expression, it will be automatically raised to the power of 2. And on the contrary, that is not going to be true, because majority of the time when you get a question that is a difference of two squares on an exam, you're going to find that one of the term is raised to a power of 2 and the other is not. But before we get to that, let's actually dive in and look at expressions that are already raised to the power of 2. So we are asked to factorize a squared minus x squared. We can skip step 1 because step 1 states that ensure that both expressions are raised to the power of 2. We don't need to ensure that because guess what happens? They are already expressed to a power of 2. So going to step 2, we're just going to open a pair of brackets as suggested here. Let's go back up here. Open 2 pairs of brackets, inserting a plus and a minus in either brackets. So we're going to insert a plus here. We're going to insert a minus here. And in step 3, we're going to take the square root of both terms and distribute them evenly in the brackets. So if we take the square root of a squared, and let me just explain that to you guys. Take the square root of a squared, that's the square root of a squared. What's going to happen is that the square root will cancel the square and we're going to be left with a. So we're going to have an a here, and we're going to have an a here as well. Alright, because a times a is a squared. And then of course we're going to take the square root of x squared, and the square is going to cancel the square. We're going to be left with x here and x here. So both brackets should have the first term, and both brackets should also have the second term. Now, doing this sort of thing on your exam paper is not something that CXC is going to necessarily, be looking for, because they expect that you should know this. So you don't necessarily have to do this square root thing. What I tell my students in my class, just to simplify, and I like to keep things simple in my class, guys, is what I tell my students is, once you have opened your brackets and you've inserted a plus and a minus in either brackets, ensure that both brackets have each letters. So I often tell them that, hey, there's 2 A's here, put 1 here and 1 here. Pardon me, guys. So if you have 2 A's here, which you're always going to have, you're going to always have 2 of this term, 2 of that term, then ensure that 1 is here and 1 is here. And if you have 2 X's here, not if, but you will gonna have 2 X's there, put 1 here and 1 there. And it just kind of simplify the thought process. Should you be wanting to teach mathematics, or you're learning how to teach mathematics with confidence, then you want to actually learn how to articulate yourself well. But my videos are geared towards helping students in building their skill set to effectively do these questions in exams. All right, so that's kind of like what we want to focus on here. So in example number 2, we end up, say here, with c squared. Let's erase that. Pardon me. That is actually c squared. Give me a second here, guys. That's a square. Okay, beautiful. So we have c squared minus f squared. We can skip step 1 because they are both already expressed to a power of 2. We can just simply put a plus here and a minus here. We're going to put a c here and a c here. We're going to put a f here and a f there. And voila, that is your answer. Very simple, right? It is. It is absolutely very simple. I do hope that you are enjoying the video so far. We are 20 minutes in. If you have made it this far in the video, of course, leave a like, leave a comment, share this out to a friend, to a family, your mom, your dad, your sister, your uncle. If you're in college, you're entering into college, you're in college struggling with math, finding a challenge with areas like this or areas higher, calculus 1, calculus 2, pre-calculus 1, pre-calculus 2, college algebra, you can get in contact with me through my socials that is pinned in the description box below. I'm willing to help, and of course these services obviously comes at a cost, but I am very dedicated towards helping my students at the most reasonable, the most affordable cost. So you can of course tap into my socials and take on to that. All right, let's continue then. Now, as mentioned before in the first 2 examples, we ignored part 1 because those examples gave us the expressions already expressed to a power of 2. So here's a tricky one: x squared minus 36. Now, when I give my students questions like these, let's say hypothetically that I leave my students to try to do this. I've seen where my students pretty much fall by the wayside. What do you mean by that? They'll kind of have an idea of what to do. I've seen students do stuff like, they'll do stuff like x squared minus 36 squared. They want both terms to be raised to a power of 2. So what they do is that they just attach a power of 2 onto the 36. Now, on the contrary, ladies and gentlemen, boys and girls, you are not supposed to raise any of the terms to a power of 2. Since the x is already raised to a power of 2, all I need to do is to find out what number do I have to square to get 36. That's the objective. What do you have to square to get 36? Again, when I'm teaching my classes, I'm teaching a wide variety of students. Students who have a lot of gaps in their learning, students who have been struggling for years, students who have serious timetable issues. So I have to use different ways of articulating myself. So one of the easiest ways, if you are not familiar with your square table or if you have gaps in your timetable learning, then what you can do then is that you can just simply find the square root of 36. So if you find the square root of 36 on your calculator, it's going to tell you that the square root of 36 is 6. Therefore, you know that the square root is 6. That means 6 squared must give you 36. Yes, 6 squared is 36. Whoops, pardon me guys. 6 squared is 36. Therefore, the square root of 36 is 6. Simple enough, right? Alright, I know you guys got that. So x squared minus 6 squared. Then we're going to open 2 brackets here. Now, notice in my previous example, I've always put the plus, then the minus. Plus, then the minus. So what happens then if a student makes what is perceived as an error and put the minus here and the plus here? Will you be incorrect? No, you're not incorrect. You are in fact correct, because the instruction did not say to put a plus in the first and the minus in the last. The instruction says to put a plus and a minus in either brackets. So therefore you can simply go ahead and say here minus in the first and plus in the last. And since we have 2 x's, we're going to simply put 1 x here and 1 x here. And since there's 2 6's, we're going to put 1 here and 1 here, and voila, that is your answer. Easy, isn't it? It absolutely is a very, very simple question. once you understand the basic fundamental principles of difference of two squares. Now, very similarly, we've just turned the expression backwards. Remember that as students, many students at the CSEC level are struggling with the memorization skill. They memorize so much that if you turn the question a little bit different, they find it a challenge. And like I said, I've been teaching math for 13 years, and a lot of the, the pass rate in the Caribbean for math, math is a horrible subject right across the world, but in the Caribbean, based on statistics that I've seen, it is in the low 30s. And so the aim of AP3X Institute is to change that. All students who watch my videos, all students who share my videos, all students who leave a comment in the comment section, you're blessed with the skill that I have garnered over the past 13 years. So you're going to be seeing all the different types of examples that you can possibly see in an exam. So say here, we just simply turn the previous example backwards. So what number do you have to square to get 81? Well, on my calculator, 9 squared, square root of 81 is 9. So I know right away that 9 squared is going to be the same thing as 81 and y squared here. Now I have both terms expressed to a power of 2. I can go ahead, open two brackets, insert a plus in one bracket, insert a minus in the other bracket, and ensure that both my brackets have the same term. So 9 on one side, 9 on the other side, y on one side, y on the other side. And voila, easy to get your answer. You can literally do this in your CSEC exam in 10-15 seconds, right? Let's move right along. All right, so now we have a little bit bigger numbers, more or less the same thing. You can see that, I've just attached a number to my letter, right? So now same procedure, square root of 36 is 6, so I know that that's 6 squared, minus the square root of 49, that's 7, so that's 7 squared, and the y is already squared. I can just safely go ahead and open two brackets here quickly, guys. Plus in one, minus in the other, 6 in the left, 6 in the right, 7 in the left, 7 in the right, y on the left, y on the right. Voila, easy. We make math simple here on this channel, and we make math fun and enjoyable to watch. So I hope you're enjoying so far 27 minutes of fun with AP3X Institute. Moving right along, all I've done here is just added a number to my second variable here. So now square root of 16, 4, so that's 4 squared. Square root of a squared, well I already have the a that is squared, so that's good. Square root of 9, that's going to be 3 squared. Square root of b squared, I don't need to do that, the b is already squared here. Now some students might say, because everybody likes shortcuts, they like to get to the answer as fast as they can. Do I have, and you may ask, Apex, do you have to write 4 squared, a squared, 3 squared, b squared? You actually don't. And I'm going to show you in the next example. I do this because I like my students to track their steps. So in case you are doing it and you get a little bit confused, you can always go back to figure out what is it that you did in the previous. And it does help with recollection. It does build certain math skills to be innate. So certain areas in math, you practice in your square table while you're doing algebraic factorization. So like I said, you can do it, it's optional. You don't have to, you can or you cannot. It doesn't give you any extra marks here. All right, so open two brackets here, and all I have to do, put a plus in one, minus in the other, put a 4 here, put a 4 here, put a here, put a here, put a 3 here, put a 3 here, put a b here, put a b here. Voila, it's like magic. Easy expression to factorize. All right, now so far we have gone through quickly within less than 30 minutes. We have literally mastered the concept of difference of two squares. Is there anything else, Apex, that they can give you on an exam that will perhaps knock you out the park? Ooh, of course there is. There is actually examples that I've seen, and I've have some for you here today in part 2 of this video. So as you can see here, well, not part 2, the second half of this video here, you have this interesting question here. I'm going to slow it down a little bit, right? And why we have to slow this down, because when these questions comes on exam, a lot of students sometimes will think this is a grouping question. Remember in part 2, we stated that difference of two squares carries two terms, HCF carries two terms, and a variety of powers, sometimes it carries three terms. So there's always that identifier in the question. So when a student sees this, and I'm thinking like I'm that student, I'm thinking that, hey, I'm not thinking this is a difference of two squares, because when I watch Apex Selenial's videos, all the examples that he's showed me so far, example 1, example 2, example 3, example 4, example 5, example 6, they've all been with two terms. So there's no way that this expression could be a difference of two squares. Well, let us take the route that hypothetical student would take. That hypothetical student sees this as a grouping question. So you're most likely going to do something like, oh, okay, this is easy. X squared minus 5x minus, okay, we know that we're going to bring the 5y to the front here, and then minus y squared here. All right. Now, some students will say, oh, but these are grouped already. But then they'll realize that, hey, oh, these are not grouped. And for the student who thinks that, oh, you can group by powers, remember in part 1, we said that when we are grouping terms, we group by coefficients and we group by variables. We did not mention that we can group by powers. Like I said, I have 13 years of experience and I have seen it all. Believe it or not, what I'm saying to you on this video are things that you guys that are watching right now would actually do had I not told you not to. So trust and believe. Let's get into it. So this is the hypothetical student working. And this is what the hypothetical student will do. Okay, so we're grouped by x's, we're grouped by y's. Let's go. X, open bracket, x is left. They've mastered your grouping technique. So the grouping is easy for them. It's easy for you. Because you watched that video, didn't you? Yes, you watched part 2. So grouping is not a problem. So x into x squared goes x times. X into 5x goes 5 times. Nicely done here. And over here now we end up with common factor of y. Then we go y here, 5 minus y into y squared. Did you hear that sound? It popped right in. That's actually a notification from Alibaba.com. And that came in right in time to let us know that we've just made a huge error. We've literally destroyed the question. Because why? We end up with x plus 5 in this bracket and we end up with 5 minus y in that bracket. So you might ask, Apex, if I took that way, what did I do wrong? You actually didn't do anything wrong. You factored the expression perfectly. What you actually didn't do was that you didn't group properly. In fact, the expression did not need to be regrouped. So you might say, of course, the expression had to be regrouped, Apex, because in the initial stage, when we looked at the expression, oh yes, guys, that is a completely wrong approach. Absolutely horrific approach there. So you might say to yourself, then Apex, this is the question. And you stated earlier that y squared cannot be subtracted from x squared. So when there's one bracket that's grouped and there's another one that's not grouped, you should regroup. So how are you going against this? Obviously, when we regrouped a while ago, it is clear that we didn't get the same things in the bracket. And this is obviously a grouping question, but it's a grouping question that contains, guess what, guys? The difference of two squares. And it also contains the HCF. and as well as it contains the grouping technique. So it's one of those questions that comprises of 3 factoring techniques. Now, let's open our third eye. Our third eye here is telling me that, ooh, here we go. That is the difference of 2 squares. So, since both these terms are raised to the power of 2, I can go ahead and use the technique that Apex showed me at the beginning of this video. X plus y, x minus y. Let's see here. So then we have x plus y, and we have x minus y. Aha! And then now we can go ahead, since these are already grouped, and let's factorize. Let's factorize, guys. So we're gonna take out minus 5 here, and then guess what happens? We have x remaining, and then negative into positive goes negative times. Don't forget that the sign outside affects the sign inside. So negative into positive goes negative times. 5 into 5y goes y times. And guess what happens, guys? We have 2 repetitive brackets. So since we have 2 repetitive brackets, it doesn't really look like your usual grouping question, but this is one of those curveball questions that we spoke about in part 2 of this video. If you haven't checked out part 2, guys, check out part 2 because we spoke about curveball questions when it comes to grouping expressions. So now we end up with x minus y in one bracket here, and then we end up with, guess what happens? 3 terms in the next bracket. So you might say to yourself, Apex, I did not know prior to watching this video that you can have 2 terms in one and 3 terms in the other. Well, now you know, guys, you can actually have that. This is a question that I saw on a practice paper way back in 2009, 2008, 2007, thereabout, that I was actually doing my exams because I passed CSEC Math with a distinction in 2009. So when I was practicing math really hard, this is something that I saw, and you know, it was quite oblivious to me. So whatever mistake you thought or you think you made, oh, I can tell you that much, I made that same mistake as well. But that's the purpose of my video, is to open your eyes so that you guys don't make the same mistakes that I did. Alright, so I really hope that you enjoyed that one. If you got it right, leave a thumbs up. Leave your comments down below. Let me know if you got that one right, guys. Let's dive right on into another example here. We're approaching 40 minutes into this class. Let's kick on here. We have p squared minus... Ooh, I write so bad. Is that 9? I think that's 9. Let's call it 9 for now. So we have p squared minus 9x. Let's double check that. Hold on, guys. I'm going to double check my material here. Just a second here, guys. Ooh. That's p squared. Hold on, guys. Let's see here. Oh yeah, it is 9. It is 9. Yes, it is 9. So it is p squared minus 9x minus q squared plus 9y. And like I said, guys, looking at this, it looks like it needs some regrouping. So we have p x q y. Interesting question. Pause the video, shoot your shot at this question, and if you got it right at the end, let me know in the comments. Let's naturally follow our instincts. There's only one p, so what are you going to group the p squared with, Apex? I know I can group the 9x with the 9y, but I don't have a q, and I don't have a p. I don't have a repetitive p, and I don't have a repetitive q. Think I want to give you guys an award if you got this one right. I think I want to give you guys a reward. Let me know in the comments what reward I should give you if you honestly got it right. guys, experience is the most important commodity that you can carry with you in an exam. Without experience, guys, without a lot of practice, without, when I say experience, I mean you've done the same thing so many times that when you see it, it becomes automatic. And right away, you see two terms that are squared. So I can therefore go ahead and say p squared minus q squared minus, let's do minus 9x plus 9y. Interesting here. Is that supposed to be a p? Oh, sorry, it's supposed to be 9p minus 9q. Thank you, guys. I'm so sorry. So it's supposed to be 9p minus 9q. So this is supposed to be 9p, which is why, okay, so I think I wrote down the question incorrectly. So I think I may have misled you guys. So let's just do this here. This is supposed to be 9p minus 9q. So that's maybe why initially we would have had a problem. So let's go back a little bit, right? Before I actually reveal the correct answer, we need to revisit what that hypothetical student would do. So this is actually the question. So we have p squared minus 9p minus q squared plus 9q. So pardon me, guys, for that misleading you there. Back to the correct question here. The hypothetical student will already see that, say here, these two terms are grouped by p's. Let's grab my pen here. So p's and by q's. So therefore, that student is going to go ahead and perhaps go ahead and say, hey, let's group these two. So let's go ahead. P squared, P is a common factor. P is left minus 9. All right. And then they're going to go ahead then and we're going to have common factor is minus q, open bracket. We're going to have q, negative into positive, minus 9. So now in one bracket we have p minus 9 and in the other bracket we have q minus 9. That is evidence that regrouping is needed. So you might ask, but why do I need to regroup? Why do I need to regroup when the terms are already grouped by p's and by q's? Well, evidently, guys, it is grouped by p's and it's grouped by q's, but our brackets are having completely different terms. It's even to the point where not only are the terms not alike, but we have two different letters representing the brackets. So it's not a case where we have p minus 9 and 9 minus p and we can turn it around. We literally have p minus 9 in one bracket and q minus 9 in the other bracket, or 9 minus q in the other bracket. It's crazy. So goes back to what we were saying, that when you get questions like these, you have to be pretty smart, pretty intuitive, pretty experienced at that, and you've got to put in a lot of practice. And of course, most importantly, you've got to be watching the videos on my channel. So we have p squared, and I'm going to group it with the q squared. Again, you might ask, Apex, why would you want to group q squared with p squared? Some students might think that, oh, maybe Apex is actually grouping by powers. But then, didn't I tell you earlier in part 1 that you cannot group by powers? You can only group by coefficients and you can only group by variables. Well, I'm not actually grouping by powers, but by me putting the q squared beside the p squared, I actually created the difference of two squares. Beautiful. And by me doing that, then you'll end up with, say here, p plus q and p minus q, right? Because we learned that p squared minus q squared is similar to x squared minus y squared, where we know that x squared minus y squared can be written as x plus y and x minus y. Therefore, p squared minus q squared can be written as p plus q multiplied by p minus q. Did you get that? You got that. I know you did. So, second bracket here, we have minus, common factor here, minus 9, open bracket, p here, minus into plus goes minus times 9, cancels 9 or 9 to 9, 1 times q is q. Guess what happens, guys? We end up with the two same things in the brackets. So then we end up easily with p minus q as a common factor. So p minus q, and then obviously we're gonna have p plus q minus 9 in the other bracket. P plus q minus 9 in the other bracket. And we have already discussed from the previous example that we are in fact allowed to have 2 terms in one and 3 terms in the other. All right, beautiful question there, right? Nice curveball question that will be sent by CSEC. If you watch this video, there's no way CSEC can trick you. All right, let's dive right on into some more examples, guys. We have, maybe I'm gonna spend another 15 minutes with you running through these examples because, like I said, difference of two squares can be a little bit tricky. So with these examples, I'm hoping that I can actually open your mind to whatever example it is that is existing out there. Now, this one is tricky, throws off a lot of students. Now, there is literally nothing you can do here, like a plus b squared minus 1. You can't subtract the 1 from a plus b. Some students might try something funny like, oh, I'm not remembering the steps, so I'm just gonna square the a, square the b, and I'm so frustrated. Oh, I don't understand. My brain is freezing. I do not remember. Okay, guys, calm down. It's not that difficult of a problem, right? I'm really starting to enjoy making my videos like this. I really want to interact with you students. I know that quite a few of you guys may be like, okay, Mr. Peart, you're really overdoing it right now. I'm actually not. I'm actually, what time is it now? It is actually 11:07 in the night. Can you believe it? It is 11:07 in the night and I'm actually doing math problems. Don't you have anything better to do with your time? I absolutely do not. I love teaching you guys and I enjoy doing math. So let's jump right into this example. Guys, do not fluster yourself. This question is too simple. It looks difficult, but it's too simple. Watch this, guys. We have a plus b that is squared. There's no need to go inside the bracket and do any squaring or expanding or doing any of that sort. We literally can, okay, so here's what we can do. All right, just to simplify this, we're going to let, watch this, guys. This is really cute, really cheeky. We're going to let x equal a plus b. Ooh, let x equals a plus b. Okay, let's see where you're going with this apex. Let x equal a plus b. So I can just replace the a plus b with what? X and square it. Oh, you're smart. Really smart. X squared minus. But what do I square to get 1? 1 squared. Now there we have it. We have the difference of 2 squares. So what's really happening with questions like these, guys, is that CSEC, or the math paper, is testing your intuitive ability, your ability to recognize that a plus b is a binomial expression that kind of just represents a letter or a number. So I could just say let a plus b be something. I could just say let a plus b be y, let a plus b be 2. I could let a plus b be anything. But just to simplify it, I just let x equals a plus b. So I can therefore then simply say that, oh, this is easy. Oh, open 2 brackets, okay? X plus in one bracket, minus in the other, x here, 1 here, 1 here. So that would have been the answer if the expression was x squared minus 1 squared. But since as we had allowed x to be a plus b, we can go right back and say, since x is a plus b, I can have a plus b plus 1, and then we can have a minus b minus 1. Was that too fast for you guys? Try rewinding the video and just slowing it down a little bit, and you'll get it. Trust me, you'll get it. So the answer is a plus b plus 1, a minus b minus 1. Now, this is what a lot of, I don't want to be prejudiced, if that's the correct word, but this is how an American would actually teach the problem. I've watched I've watched hundreds, thousands of American videos, American instructors, right? And this is kind of the way how you teach a mathematician who is learning math, or a person who wants to become a mathematician or learn how to teach mathematics. I mean, guys, it's not that complicated, really, right? You can do it like that, and we don't have to make it that complicated, right? We can just simply just get the experience and just learn that should we see a term like, say, a plus b squared, it's just literally a plus b is just a letter, right? So we can just say, we're just gonna open two brackets here. Pardon me, guys. Oops. Okay, let's grab that. Okay, there we have it. All right, I think I lost my page for a little bit there. Okay, so there we have it, guys. We're back. We are back. So a plus b squared is just like saying x squared. So literally, I'm going to open two brackets. I'm going to put a plus in one and a minus in the other. I'm going to have an a plus b because it's just one term that is squared. And we're going to have a plus b here. And then we're going to have plus 1 and we're going to have minus 1. All right, so I don't know which way you prefer. Let me know in the comments, guys. Let me know in the comments. What do you prefer me doing that whole let x equal a plus b type of thing, or do you just kind of like, okay, let's just get on with the business? Either way you do it, guys, if you do this on CSEC, you're going to be correct. All right, so take whatever approach is suitable for you. All right, now this particular example is not very common, and funny enough, I've not seen a difference of two squares that is fractional. I've only ever seen these in textbooks. I'm actually looking at a textbook right now that has 1, 2, 3, 4, 5 examples of this. 5 examples of this. So it's not a lot of these that exist, but like I said, math can be expanded in all forms. So just in case, guys, just in case 2025 is the year that CSEC comes with a question that we've never seen before, you can safely tell the world that you saw this first on Apex Institute of Mathematics Education channel. Let's jump right into it here. So nothing has changed, guys. X is squared, y is squared. We're going to just say x squared over square root of 81 is 9, so that's 9 squared, minus y squared, square root of 49 is 7, so that's 7 squared. Now that both expressions are expressed to a power of 2, or all the terms in the expression is expressed to a power of 2, we can open two large brackets, insert a plus, insert a minus, and now we're going to have x on top, we're going to have 9 at the bottom, we're going to have y on top, and we're going to have 7 at the bottom. In that bracket, we're going to go to the other bracket, we're going to have x on top, y at the bottom, we're going to have, we're going to have x at the top, 9 at the bottom, y at the top, 7 at the bottom. So our final answer then is x plus 9, our final answer is x over 9 plus y over 7 multiplied by x over 9 minus y over 7. I'm in a little bit of a vibe, guys. I'm talking a little bit too fast. So I'm actually going to slow down my speech and take you into the final phase of this example here. All right, so the remaining examples, as you can see there, guys, we looked at some questions that has a connection between the difference of two squares and the grouping along with a little bit of HCF. And now we're going to be looking at an examples where we have the difference of two squares tied with HCF only. No grouping. All right. So my experience is the crucial part of the way how I teach. How I teach is based on my experience. I don't assume that a student is supposed to know something. I just ensure that they know it even more than they have already known it. All right, so here my experience has showed me here that I've had quite a bit of students that have some way somehow tried to find a number to square to get 27. And that is actually not possible because, of course, 5 squared is 25 and 6 squared is 26. So the numerical value that you would have to square to get 27 would actually be between 5 and 6, which would obviously be a decimal number. So we don't want a decimal number. It's not that complicated. So what we're gonna do here, guys, is simply factorize by the HCF. Since there is nothing to square to get 3 and there's nothing to square to get 27, but if we take a closer look, guys, let's take a closer look here. You'll find out that 3 and 27 have something in common. So clearly then that 3 and 27 has a highest common factor of 3. Wow. So, simple question, Apex. We'll take out the 3, write back the x squared, minus 3 into 27, 9. We're done. Done. Easy question. How is that a difference of 2 squares? That is not even a challenging question, Apex. That is an easy question. At least so you thought. Because when you get questions like these, CSEC is so tricky. And I've been watching them for many years. It's just now that I've gotten the platform and the confidence and the resources to really let you know that CSEC uses a lot of non-verbal communication. There are times when you look and check it out for me, guys. Check on any past papers. There are sometimes on question 2, CSEC will say factorize the following. And then they have another time where they'll say factorize the following completely. So why would they say factorize completely and then they say factorize? Because when they say factorize completely, what CSEC is trying to say non-verbally is that the expression that we want you to factorize actually has a double factoring technique in it. It means that the expression actually has 2 factoring technique. So after you factorize by the HCF, there's more than likely going to be an expression there that requires you to factorize again. Aha! So what do you mean factorize again, Apex? Look closely, guys. Look closely. That looks just like the difference of 2 squares. So you can therefore take the 3, open the bracket here, open the bracket here. Ooh, not yet. Remember, this is how we teach it. We're going to have 3 open bracket, x squared minus what number do we square to get 9? Oh, time's up. 3 squared. So therefore then, 3 open bracket, open bracket, open bracket, open bracket, close bracket, open bracket, close bracket, x plus x minus 3. Voila. Easy. Simple. Is there any other channel on YouTube that makes learning math easy? Please name the channel in the comment section and I will be sure to adapt that channel's style and I'll bring it back to the channel. Learning math is fun with Apex. Learning math is fun. mastering CSEC exams is easy if you are subscribed to this channel. Fail not in the name of mathematics. Now, very similar, there isn't a number that you can square to get 8, and there isn't a number that you can square to get 2, guys. So do not get this question wrong. Just grab the 2, open the bracket, a squared, 2 into 8 goes 4 times. We are done. No, we are not. We are not finished, guys. Absolutely not. Because we can therefore find the number to square to get 4. What number is that? Dun, 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 dun. Times up, 2 squared. So therefore, 2 open bracket, close bracket, open bracket, close bracket, plus in one, minus in the other, a here, 2 here, 2 here. Guys, can't you do this question in 20 seconds in your exam? We are doing well. We are doing well, guys. Let's run through the remaining questions. We are a little bit over an hour, and I did not expect that this video was going to make it to an hour long. But let's kick on here, guys. We are going into this. Now, this question gets... many of my students get caught when it comes to this question. They lose or have a lapse in concentration, and they do something like this. 9a squared. That is like the worst way to get a question like this wrong, when the instruction clearly says to factorize. Because if you do something like this, it's going to pain my heart, and I'm going to ask you to unsubscribe from the channel. Because on my channel, we do not teach you to do stuff like this. You cannot subtract unlike terms. So just in case subconsciously you were planning to do something like that, unsubscribe if you did that. No, I'm just kidding. Do not unsubscribe. Do not unsubscribe. Do not unsubscribe. Do not unsubscribe. Subscribe even more to the channel. Leave a like, and let's continue. Let's find out the solution to this. The common factor here is going to be 3. You guys must be tearing up inside. You must be enjoying this video. I can see the smile on your face. Let's take the common factor. Oh, she's 3. 3 into 12 goes 4 times. 3 into 3 goes 1 time. Do we write the 1? Do we write the 1? We don't need to write the 1 because the a squared is left. And once again, look at that. 4 minus a squared is very similar to a squared minus 4 that we just did. So the questions are similar. Let's go. So we're gonna go ahead then, and we're gonna have 3 open bracket. What do I have to square to get 4? Dun, dun, dun. We already got that, guys. It's 2 squared minus a squared. So therefore then we have 3 open bracket, close bracket, open bracket, close bracket, plus in one, minus in the other, 2 here, 2 here, a here, a here. Voila, we're done. Easy. Let's run through the rest. Common factor here is 10. There is nothing to square to get 10. And if you guys tell me 5 squared, I'm going to cry. 5 squared is 25. Oh, sir, I made a mistake. It's not a mistake. You're lapsing concentration. Stop lapsing, guys. Let's get it. Common factor is 10. Open the bracket. E squared, 10 into 10 goes 1. Do you hear that? That's a scratch on the head. Because e squared minus 1. E squared minus 1. What do I square to get 1? Is that even possible? It is, because 1 squared is 1. So e squared minus 1 squared. So that's 10, open bracket, close bracket, open bracket, close bracket, plus in one, minus in the other, e in the left, e in the right, 1 in the left, 1 in the right. Voila. Isn't mathematics a beautiful language? It's beautiful when you're having fun and when you understand. And so to bring this video to the end, we are a little bit over an hour, which is longer than I had planned to stay here. But guys, I had so much fun making part 1, 2, and 3. I'm going to have even more fun making part 4. In fact, I actually have a video that's already available on my channel that discusses part 4, explanation version and the example version. That's an old video that I made about a year, maybe a year and a half, going about 2 years ago. So I want to remake that video because I think I have a little bit more vibe, a little bit more energy when making this video. So gonna check out that one. I will leave a link pin in the description box below to that older video if you find older videos more exciting. If you like this type of teaching and if you like this type of video that I'm now introducing to my channel, then please subscribe, leave a like, leave your comment, share it down into your math community, friends, family, mother, sister, father, brother. Anybody who has ever wanted to do math in their life cannot fail if they're watching any of my tutorials. Let's bring it to the end. We have 4 squared. Why am I writing the question over? Let's go. 4 squared minus 16y squared. Oh, this is easy. 2 squared x squared, 4 squared y squared. Sir Apex, I've watched all your other questions. You can't trick me with this one. I don't think I can. I absolutely don't think I can. Open the bracket, open the bracket. Oh, sorry. Open the bracket, close the bracket. Open the bracket, close the bracket. 2 here, x here, plus here, minus here. Okay, so 2x, plus minus. 4 here, y here, 4 here, y here. I'm done. Easy. Incorrect. What are you talking about? You just went through several examples showing me that that's what I'm supposed to do. Well, guys, you are technically right, but you're also technically incomplete. Because these 2 brackets still have something in common. So if you want, you could continue from here by pulling out a 2 and just making a mess of the whole question. What was oblivious to you guys there was the fact that there was actually a common factor in the first place. So sometimes you tend to be so confident, you've also be very mindful of being too overconfident. This caught me the first time I did it. So guys, always look out for the highest common factor, because when you are factorizing completely, at the end you should have nothing in common. So here, let's bring this video to the end. I think I'm elaborating too much, guys. 4 is a common factor, guys. I think I'm enjoying myself a little bit too much here. So 4 is a... Come on. 4 is a common factor. Open the bracket. X squared minus 4y squared. Okay, so alright, fine. So we're gonna have 4 open bracket x squared minus 2 squared y squared. Alright, perfect. We're gonna have 4 open bracket, close bracket, open bracket, close bracket, plus here, minus here, x here, 2 here, 2 here, y here, y here. Notice what is in the brackets, guys. There's nothing common. We had 2x plus 4y and 2x minus 4y. That was an incomplete factored expression. So therefore then, very clearly, guys, if you look here, that we have nothing here in common. Now, at the end of this video, you guys absolutely, and when I say absolutely, cannot see a question on your CSEC exam that is related to the difference of 2 squares that you cannot solve. I promise you, and I've have 13 years of experience, plus a few more years as a student, plus I have college experience. I've seen it all. There's literally no question at this level that CSEC can give you that you won't be able to capture that 2 marks, 1 mark, or whatever marks they're going to offer for that question. Alright, I do really hope that you enjoyed this video. It was fun making this video, and I hope that you enjoyed it as well. If you do not forget to subscribe, guys. Subscribe, hit that notification bell. Even if you pass math, still subscribe. You don't have to watch the videos next year because you're going to be a grade 1 student. You can just pass on the subscription to other students that are coming up. Alright, and if you do enjoy the video, you enjoy my theatrics, you enjoyed my voice, you enjoy the way how I teach you, then of course leave a like, leave your comments. Guys, I'd love to hear from you. You guys are not commenting, hey, good video, hey, thank you, hey, this helps me, hey, that helps me, hey, you know, just leave, say something. Give me that word of encouragement. Help me to continue making videos. And of course, share this out to your mom, your dad, your sister, your brother, your uncle, your aunt, your nephew, your upcoming children, your unborn child. Share this out to your math community. Alright? And of course, if you guys would like to get in contact with me to join my live classes that I keep on a Tuesday and a Thursday, you can definitely do so by connecting with me in the socials that is pinned in the description and in the comments down below. Guys, I thank you so much for watching and supporting the channel. The road to 1,000 subscribers is on its way. Until next time, this is Apex Elenio signing out. Keep on practicing and improving and becoming a better math student. Until next time, take care. Bye-bye.